Hi everyone, welcome to BTech Quality Stats 3 class group project. The group members for this project are as follows: Akona Sioyo, Amandla Mangisa, Piliswa Chako, and Yandisa Mbeu. Let's give you the outline to the project. We will introduce you to statistics and probability. We will give you the concept, which is binomial probability, and then we will show you when to use binomial probability. We will also derive the binomial formula, and then show you the link between total quality management and binomial probability formula. We will show you a scenario to the project as well as the data collected. We will have calculations in Excel. We will have our conclusion and our references. Okay, let's start by answering what is statistics. Statistics is defined as the science that deals with the collection, tabulation, and systematic classification of numerical data being data that is measurable, such as time, height, weight, the amount, and so forth. It is also a collection of mathematical techniques that helps to analyze and present data. Simply put, statistics is a way to convert numbers into useful information so that good decisions can be made. Statistics also helps condense data and present it in a manner understandable by everybody. Now let's answer what is probability. Probability is the measure of the likelihood that an event will occur. We'll show you what we mean by this in the following slide. Probability quantifies as a number between 0 and 1, where 0 indicates impossibility and 1 indicates certainty. Now let's show you what we mean by probability of an outcome occurring. Here we spin a coin 2 times, and the outcomes that are possible that can occur here, well, definitely that will occur are you get a head and a head, you get a head and a tail, you get a tail and a head, you can also get a tail and a tail. Now let's go to the concept, which is binomial probability. What is binomial probability? Binomial probability refers to the probability of observing a specified number of successful outcomes in a specified number of trials or experiments. Binomial probability is sometimes referred to as the Bernoulli trial, and that is because it is named after Jacob Bernoulli, who was a 17th century Swiss mathematician. Now, when do you use binomial probability? You use it when there are only 2 outcomes, that is success or failure, and that is why we have the bi prefix in the word binomial. You also use a binomial when your trials are independent. By that we mean that the outcome of one trial is not dependent on the outcome of another trial. You also use it when there are a fixed number of trials, meaning that you have your experiment with replacement. Now let's go to deriving the binomial formula. The binomial probability formula is written as follows: C capital letter N, comma, small letter n, multiplied by small letter s in brackets to the power small letter n, multiplied by small letter f in brackets to the power of capital letter N minus small letter n. Let's explain what this formula means. The C capital letter N small letter n is your combination. A combination is, of course, a loose arrangement of a set of objects. By this we mean that you can arrange the objects in any way. They don't have to have a specific order to them. Small letter s is the number of successes. Small letter f is the number of failure. N is the probability of a success on an individual test or an experiment. The capital letter N is the number of trials or experiments that you do. Okay, now let's show you the link between binomial probability and total quality management. TQM is considered a customer-focused process and aims for continual improvement of business operations. It strives to ensure all associated employees work towards the common goals of improving product or service quality, as well as improving the procedures that are in place for production. With the scenario we have in this project, we will use binomial probability to give the quality manager a clear indication of what are the chances of him getting a conforming or a non-conforming results for a caffeine. Now, binomial probability and total quality management work hand in hand. By doing risk-based thinking, the quality management will be able to detect what could go wrong before it even goes wrong. The quality manager will also know what's causing deviations in their process. This will then help them to place preventive controls to minimize negative effects. This will also help them to reduce the number of recalls. Now, this is the scenario we have for this project. We have a company here named Dynamic Pharmaceuticals, which produces Anofen, a tablet used to treat epilepsy, which received a number of complaints that they were having insomnia after taking the tablet. We do know that Anofen contains caffeine, an active that causes insomnia when taken in large quantities. So the company had to do an investigation to find the root cause of these customer complaints about Anofen. What the quality assurance manager did was basically hire QTEX quality consultants to help him with this situation. And then the consultants, what they did was over 3 months, they selected 2 samples. And then this equaled 6 samples in total, because it's 2 multiplied by 3 of Anofen, replacing the samples every time. Now we will be performing our calculations to the scenario in Excel. Now what we see here in Excel is the data that was collected by the QTEX technicians. For caffeine, we have our lower limit, SOP lower limit, we have our SOP upper limit, and the results that were produced by the manufacturing process. Now when we go down, we will see how many batches were manufactured by the company. Let's scroll down. There were 120 batches manufactured, and out of that we had 30 results that were below specification, as we can see here, and we had 19 results that were above specification. So now we will be calculating our probability for getting 3 results that are out of specification from the data collected by the technicians. This will use our binomial probability formula. We've already here listed all the parameters in our formula for the probability formula, which we saw on the previous slides. Now n, which is the number of trials, is basically equaling to 6, because there were 6 samples sampled by the technician. Now our small letter n, which is the probability of getting 3 that are out of specification, is equaling to 3, equals 3. That is our small letter n. Now S is now the probability which of a success. Our success is the probability of getting 3 that are out of specification. Now when we see here, we see that there are 49 that were produced that are out of specification out of the 120. So our S is basically equal to 49 divided by 120, which equals to 0.408333. Small letter f is the probability of a failure out of all these results that were obtained. Now our small letter f is of course equaling to whatever is left when you minus the 149 out of 120, which is basically 71 divided by 120, which equals to, of course, 0.591667. Now C6,3 is our combination, because the 6 is our number of trials and the n is the probability of getting 3 that are, of course, out of specific. Now the combination, of course, is equal to, here on Excel, combine. Then you click on combine there. then you put 6, then you put comma, 3, and then you enter. Oh, pardon me, I am supposed to close the brackets here, of course, and then you close the bracket. Excuse me, sorry guys. You put 6, comma, 3, close brackets, and then you enter. Sorry guys. Reason why we are not getting an answer for this combination is because of the setup of my Excel. So my Excel uses a semicolon instead of a comma. So let's go this over again and use the correct, basically the semicolon. So our combination is equal to combine, okay, double click there, 6, and then we put the correct one, which is the semicolon, 3, we close our brackets, and then we enter. Now you see we get the combination that is equal to 20. Now we come to our probability of a success to the power small letter, and we are going to be calculating that now, and that of course is equal to basically that which is our small letter s power to the power, we put our semicolon and we say power. Our power, of course, of small letter n is 3. Our small letter n is 3. Then we close the brackets there. And then we enter. Okay, pardon me. We seem to have a small glitch here. Alright, let's continue with multiplying, with calculating our small letter s to the power n. That is, of course, now the correct way of calculating this is basically you say your formula is equal to power, double click on power, and then you go to the number that you want. In this case, we want that number, and then we put semicolon, and then the power is of course 3, and then we close our brackets, and then we enter. Now that is our answer to our probability of success to the power small letter n. Now we are going to be calculating now our probability of n to the power capital letter n minus small letter n, which of course is equal to power 3, because small capital letter n minus n is also 3 because it's 6 minus 3. So it's basically power, the number, our number of course for that is that one for f, and then semicolon, and that of course to the capital letter to the small letter n, which is 3 because it's 6 minus 3, and then we close our brackets, and then we get our answer there. Now to calculating our probability for this equation is as follows. Our probability is of course equaling to, we put our formula equals to our combination multiplied by our answer for that, and then multiplied by of course our answer for that, and then we get our result. Now that's our probability for basically our equation. This is what we get, the answer for this probability. Now let's go to our conclusion to conclude what does this tell. Okay, in conclusion, our probability in 4 decimal places is 0.2820. Then this multiplied by 100 gives us 28.20%. This of course tells the manager that there's 28% probability of getting non-conforming products, which needs measures to be put in place to address the deviation. Those are our references. Thank you.